We're coding again. This time I don't have that glitch. Oh, and I guess I'm also getting desktop audio.
Input dot is action pressed
Nice.
UI left. Okay, this is something that I would do in GameMaker a lot of the time.
Okay, let's see here. I like maybe picture in picture would be more helpful. Func input access vector 2.0. Then we need var access.x equals input. Input is action pressed. Weird.
Which is a very common thing. I think Sean Spalding kind of popularized it with his videos, but you will get whether or not they're pressing the right key, and if they are, this would return 1, and then whether or not they're pressing the left key. Let's say they are pressing the right key, but they're not pressing the left key, then we get 1 minus 0, which would just be 1, and that would be, our x value would be 1, so positive 1. If they're not pressing the right key, and they are pressing the left key, this would be 0, this would be 1, so then would be negative 1, which would be to the left. Negative 1, and axis of negative 1 would be to the left. So it's a really clever trick. However, we've got a problem. Oh, first of all, we need to remove the var statement there because we've already declared that variable up here, so we don't need to redeclare it. But the problem is that these values return a bool, which is true or false. We need to convert them to an int, which would then give us a 0 or a 1. So we just type int parentheses, and then add our ending parentheses here.
You fool, what are you doing? Except I forgot to put the var in front of this one, so I had the opposite problem. Equals int. Oh wait, no, I did have the var. I just wasn't scrolled over enough. And I just put on overtype. Turned it off. What later deleted that, and that didn't count as a new line. I don't know, it's fine.
To encapsulate this function, and then we'll do another one right here, int, and end it here to encapsulate this bit here. To call it on this. So we're going to do the same thing but with the y value. Exist.y equals int input.is action pressed. And for this we're going to do down first, and then up. Just like that. So we've set the axes. Now we want to normalize this vector.
Did I just do that backwards? Down minus up. Oh, bad idea.
And what that basically means is, let me show you here real quick. If we open up paint.net, let's say we have our vector right here. Here's our, that was not a very straight line. Here's our Cartesian plane. I can't pronounce that right now. Okay, so let's say we've got our point 1, 1 right here. That vector right here, this vector, would have a length of greater than 1. Because you can see if it was actually 1, it would be around this circle like this and somewhere around here. So its length is greater than 1. However, let's say we had just a vector of 1 in the x. So this right here would be 1 in the x and technically negative 1 in the y, right? This one down here, let's say it is 1 in the x and 0 in the y. This one right here would have a length of 1, okay? So if you normalize a vector, what it does is it makes its length 1. No matter which direction it's pointing or how long it is, it always just cuts it off right at this circle and makes its length 1. And this is a very, very scribbly drawing, but that gives you the general idea of what we're doing here. So we can say return axes dot normalized. And this function right here will just give it a length.
Okay.
Length of 1. And that's beneficial. That way we don't move faster at diagonals than we do at the cardinal directions. If you remember, a lot of times when you're making a game, that's a problem that needs to be solved. And a lot of older games, they would actually just leave it. So you just move faster in diagonals than you would at the cardinal direction. So this fixes that for us. And then we return that value back out. So our get input function is now working. So let's apply friction. So here's how we're going to do the friction. We're going to say if motion.length is greater than the amount, so the amount of friction that we want to apply, then we'll say motion minus equals motion.normalized times amount. So
if motion.length is greater than amount, motion minus equals motion.normalized times amount.
we're taking our current motion, and then we're normalizing that same motion, and we're adding, or we're multiplying it by the amount. So let's say our friction amount is 10, for example. Then this vector is going to have a length of 10. So if we come back into here, let's say, don't save, let's say we're headed in this direction, and our vector length is 100, okay? So what we're going to do is we're going to subtract this same vector, so let's take that same vector, but we're going to normalize it, which would give us a length of 1, right? Normalizing it would give us a length of 1. And then we multiply that by our amount, which let's say is 10. Then we're going to get a length of 10, right? So then this is a length of 10. Let's say that's a length of 10. We're going to subtract this vector from this vector, which would basically mean that we're going to go in the opposite direction of 10, like this. So we're taking our motion that was this amount, 100, and after we subtract the 10, it's going to be the same direction, but instead it's going to be 90 instead of 100. So that's what our vector math is doing right here. And once we've done that, that bit's done. However, if the motion.length is less than our amount, then we're just going to want to be at 0 at that point. So we'll say motion equals vector 2.0, like that.
Motion equals vector 2.0.
Okay, now let's apply our movement. So this one's pretty easy too. First, all we have to do is do motion plus equals amount. So that's just going to add our new amount. This might be acceleration. Let's name that better. We'll name it acceleration like this. So this is our acceleration vector. Whatever it is, we'll add that to our current motion vector.
Okay, so apply movement, excel. I'll just stick with excel. Motion plus equals excel.
And that's it. However, we do want to cap our speed to make sure that we never go faster than our max speed. So in order to do that, we can say if motion.length is greater than max speed, then motion equals motion.normalized. Remember, so we're taking our motion, but we're setting its length to 1. Then we can multiply that by our max speed. So that allows us to set our motion to the max speed.
If motion.length is greater than max speed, now, we had a length in here, right? And that's the same here as motion equals motion.normalized times max speed.
Now there's another way to do this actually. I just remembered. You could use the clamp function, I think, which is part of the vector class. So we could say motion equals motion.clamped, and then just pass in max speed, like this. So that's actually a better way of doing it, because then
okay. Motion equals motion.clamped max speed.
clamp function does the math for us, and it would be a little bit faster. So we'll just do that instead. But the other method works as well. So we can save, come into our world, and run the game. It's going to need us to select a main scene, so we're going to select our world scene for that. And our character should be able to move around.
Does this work? Woo! Ooh, that's pretty fancy. There's a bit of blur to it. I wonder why. It's actually really high quality. Oh my goodness. Probably want it to be a little jumpier, but then again. That is, unlike the last game, this actually has really satisfying motion. I was thinking of a top-down shooter, but this could be something else. This could be like a I made this all by myself. I did it all by myself.
In this world, it's got really nice, smooth movement. And of course, you can play with your acceleration and max speed values in order to get a different feel for the movement of the game. So let's add some items that we can collide with. We'll add in a rigid body 2D, or a static body 2D, and it needs a collider, so we'll add a new collision. Instead of doing a shape, we'll do a collision polygon. And so in order to do this, we're going to actually set snap on. So we'll come up here, we'll configure snap, we'll do 32 by 32, close. We'll turn snap on by clicking on that. You can see we get our grid now, but then we'll also click on view and show grid so we can see this area. Then when we have the collision.
Okay, let's go and make this thing. So, child node. Let's get a static body 2D that has a collision polygon 2D.
Polygon selected, you'll see these new buttons up here. And we'll click on the green one. This will allow us to add new points to the collision polygon. So I'm just going to click there, and then click here.
Okay, we also need to turn on. Whoop. Better go back like 10 seconds, 15 seconds. Also, Heartbeast is the one who made the video, so go check him out.
A rigid body 2D, or a static body 2D, and it needs a collider, so we'll add a new collision. Instead of doing a shape, we'll do a collision polygon. And so in order to do this, we're going to actually set snap on. So we'll come up here, we'll configure snap, we'll do 32 by 32.
Okay, so go up there. What is this? Oh, that's the game. Snap on. Grid step 32 by 32. Oh, wrong with you. Show the grid. Alright, Firefox, do your magic. Oh no, I have to reconfigure the window size.
Close. We'll turn snap on by clicking on that. You can see we get our grid now.
Turn snap on.
But then we'll also click on view and show grid so we can see.
View. Oh, well, it's already showing grid.
This area. Then when we have the collision polygon selected, you'll see these new buttons up here. And we'll click on the green one. This will allow us to add new points to the collision polygon. So
why am I doing this with my trackpad?
I'm just going to click there, and then click here, and click here, and click here, and maybe here. And then I'm going to make some shapes here. Something like this. And then I think I can click on that and then click up here. So we've created this weird collision polygon shape for our static body. And I'll just save the game. And then in debug mode, we're going to do visible collision shapes. If I click up here, click visible collision shapes. This will allow us to see the collision shapes while we're moving around.
Oh, okay. Visible collision shapes. Where's the edges of my screen? I want to move my player to the middle. Alright, let's play this thing. Look at that. Why is my white circle blue? Oh, because it's showing the collision body. I bet like there's definitely got to be some functions where like you could like apply force to this. So what if maybe there could be like multiplayer pinball game. Spitballing here. But somebody controls the flippers. The other person controls, like, I don't know, a magical pinball. Where you have relative control over these kinds of things. And, like, it would need to be a cooperative game. Where, like you both need to work towards, like, trying to get a high score or whatever. That could be fun. Anything else in this tutorial?
In the room. And you can see we've got nice, smooth collisions with these edges. Our character can move around in this world. So that's going to be it for this tutorial. I'm planning on doing more tutorials kind of like this, some simpler ones. I'm also working on a new course for Godot, and I'm still working on my games. Once I've kind of got the course started, I'm going to be doing tutorial content and course content, like support and stuff, on Mondays, Tuesdays, and Wednesdays, and then going to be working on my game on Thursdays and Fridays. That's the current plan. My 2 games, actually. I've got 2 in the works right now. But so I'm excited to tell you more about the course, and if you want to follow my Twitch channel...
Now when I do that, it just pauses the video. Dude, Firefox is the greatest. I really like this. Oh, wait, nope, not mean to do that. I meant to move my screen. I think that could be a lot of fun. Okay, well, that's all. Goodbye.